Hello, everybody. Today I'll be presenting my paper entitled Potentials and Impacts of Selected Negative Emission Technologies in Light of Green Process Engineering. My name is Maria Victoria Migo Samagang from the De La Salle University. Nations have agreed to keep the global warming temperature well below 2 degrees Celsius during the Paris Agreement. The priority solution is to decarbonize or turn away from fossil fuels, so that the industries are now being pushed to pursue a low carbon economy. However, climate models have shown that in addition to decarbonization, we need negative emission technologies or nets to limit global warming. Nets remove carbon from the atmosphere and store it in the soil, underground, or other environmental compartment so that the resulting atmospheric concentration is lower. For the examples of nets, we have afforestation and reforestation or AR, where the trees are planted to expand the forest area and maximize the carbon sink. Wetland restoration or WR, where mangrove swamps are restored to support the anaerobic storage of dead organic matter. Soil carbon sequestration, or SCS, takes advantage of land management options to enhance the capacity of soil as carbon sink. Biochar application to soil improves soil quality and stores carbon dioxide from the atmosphere into the soil. Enhanced weathering, or EW, it's where the carbonate and silicate weathering activities of rocks are fast-tracked by the addition of silicate minerals to the soil. Bioenergy with carbon capture and storage uses renewable biomass, which captures the carbon dioxide during photosynthesis, but instead of releasing the exhaust carbon dioxide into the atmosphere during energy conversion, it is captured, thereby resulting in negative emissions. Lastly, we have direct air capture, or DAC, which absorbs carbon dioxide directly from the atmosphere using amines or sodium hydroxide scrubbing systems, or other technologies. As with any other technology, nets both have positive and negative impacts when implemented in the large scale. Green process engineering emphasizes sustainable technological and process design that have minimum impact on the environment and human health. In implementing nets on a large scale, it is therefore important to consider green process engineering for sustainability and protection of human welfare. Nets have been evaluated according to the UN SDGs, but no studies have been found evaluating nets according to the green engineering or GE principles. Thus, this paper evaluates the various features of the selected nets as mentioned and identifies the green engineering principles positively and negatively impacted by each net. The impacts of the nets were then assessed based on the 9 and 12 versions of the green engineering principles using the identifiers as shown in the table. Moving on to the results, the table shows the positively and negatively impacted GE principles for each net. But for the discussion, let's move on to the diagrams. Each Venn diagram shows a GE principle and the surrounding circles show the associated net. The green color means the net positively impacts the principle, orange means the net negatively impacts the GE principle, and lastly, yellow means the net both negatively and positively impacts the GE principle. For principle N2, which is conserve and improve natural ecosystems while protecting human health and well-being. It's positively impacted by these nets. AR can produce food, fuel, and fiber while providing habitat for biodiversity through its forests. Wetlands provide fish, shrimp, while sheltering biodiversity. At the same time, it helps fight pollution by filtering pollutants from air and water. Soil carbon sequestration can improve soil quality and soil biodiversity, like SES, biochar application to soil improves soil quality and biodiversity, and it also has pollution filtering capabilities. EW or enhanced weathering can reduce ocean acidification, thus protecting the natural ecosystem, and it can also improve soil quality when applied to the soil. However, if the rocks that will be used will come from mining, then it also negatively impacts Principle N2 since mining has a poor track record in the environment and human welfare. That's why it's color yellow. Since all the nets except for DAC require significant amounts of resources like land, water, and nutrients, they negatively impact Principle N5, which is minimized depletion of natural resources. However, since AR can produce food, fuel, and fiber while providing habitat, it's in line with Principle N5. Similarly, wetlands provide shrimp, fish while sheltering biodiversity. So AR and WR require natural resources, but at the same time they also give back to natural resources. That's why they're color yellow. Nets are actually a treatment rather than a prevention to the carbon emissions problem. Hence, they negatively impact Principle N2 or prevention instead of treatment. Decarbonization and turning to renewable energy is the prevention, but nets is the treatment. Having nets as an option might hamper the current carbon dioxide reduction efforts. Nevertheless, studies showed that both decarbonization and nets are required to fight climate change, but nets is not a substitute for decarbonization. BECS and biochar, on the other hand, are exempted from negatively impacting Principle T2 because both BECS and biochar are renewable energy sources. They are carbon neutral. Because AR and WR, biochar, and BECS all involve biomass, which is a renewable resource, they all support Principle T12, or renewable rather than depleting. Enhanced weathering, BECS, and DAC are relatively stable in storing carbon dioxide carbon compared to the other nets. Hence, they support Principle T7, which is durability rather than immortality. On the other hand, AR, WR, SES, biochar reach zinc saturation over time. Some studies note that AR has an effective lifespan of 20 years, while biochar has 100 years, and thus these nets impact Principle T7. Lastly, Principle N8, BECS and DAC, or bioenergy with carbon capture and storage, and DAC are now focused on research innovation the supporting Principle N8, which is create engineering solutions beyond current or dominant technologies, improve, innovate, and invent to achieve sustainability. Enhanced weathering is also gaining attention in research and development, especially using mining wastes. In conclusion, all nets both have positive and negative impacts on the green engineering principles. Afforestation and reforestation, wetland restoration, soil carbon sequestration, biochar, and enhanced weathering positively impact Principle N2, or conserve and improve natural ecosystem. But for enhanced weathering, it also negatively impacts Principle N2. Almost all nets negatively impact Principle N5. It is recommended to integrate the green engineering principles during the planning and large-scale implementation of nets for sustainability. This is now end of my presentation. Thank you very much.